Hello everyone and welcome to today's webinar. My name is Jorge Jimenez and I am a Senior Program Specialist at Hirose. I will be leading our conversation today about USB connectors, especially USB Type-C for industrial applications. USB standards have been around since the 1990s. The standards cover both specification and connectors. The specifications include signal, speed, and power. Additionally, the standard covers the variety of logos associated with the various specifications. The journey of USB standards has been fascinating and at times very confusing. But today we will focus on the USB connectors leading to the USB Type-C for industrial applications. Let's start by introducing our panel. First, Pete Lace.
Hi, Jorge. My pleasure to be here.
Glad to have you here. Pete is an Assistant Vice President of Product Management at Hirose. Pete plays a pivotal role in connector strategy and addressing features for the industrial market.
Yes, sir.
We also have Gary Hardesty. Hello, Gary.
Hi, Jorge. How are you?
I'm doing fine, thanks. Thanks for joining us today.
My pleasure.
Gary works for Tecnova, and Gary is a Senior Electrical Engineering and Project Manager. Tecnova is a consulting firm focusing on industrial clients, helping them address hardware issues and manufacturing challenges. Pete, can you share us more about your role at Hirose and the role of innovation in connector industry?
Sure. Thanks, Jorge. My name is Pete Lace. I'm the AVP of Product Management here at Hirose Americas. My team has three primary objectives, one of which is to help shape the roadmap for our future products. You asked me about my perspective of connector industry innovation and evolution, and what really comes to mind for me is actually Moore's Law. So Moore's Law has to do with a chip's performance versus its footprint over the course of time. And so specifically for a given footprint, a chip's performance will double in its performance every 2 years. Or conversely, if you keep the performance on par, a chip's footprint should decrease by half over 2 years. And so one product that readily comes to mind from Hirose is one of our latest IOs, and this is our IX Industrial Ethernet connector. Now, when you think about Ethernet connectors, typically the RJ45 comes to mind, right? It's been in the industry for 50 plus years right now, and we're actually looking to retire the RJ45 with this new IX. And the IX has two compelling reasons in terms of doing so. One is the IX's volume is 75% smaller than the RJ45. That's pretty big, pretty small, I should say. And then secondly is the IX is much more robust than the RJ45. And so, here at Hirose, innovation is at the core of what we do. We hold over 5,500 patents. We have numerous product innovation awards, and we have several market firsts, including our U.FL connector, our flip-lock ZIF connector, and this IX industrial connector that I just mentioned. Hirose enablers, basically, we make connectors smaller, faster, more robust, and easier to design and manufacture with.
Pete, partnerships are very important. Tell us about Hirose network partners.
Absolutely. So partnerships are more and more important these days. If you just think about the systems today and where they're going for tomorrow, systems are getting smaller, more complex, higher density, if you will. And so it's to one's advantage to have a partner that has shared market focus and related type of experiences. Hirose's Design Partner Network was established a little under a year ago, and the main premise behind it is to add technical expertise beyond just the connector. So this would be perhaps at the board level, the subsystem level, or even at the system level in some cases. And we've partnered with several third-party design companies, one of which is Tecnova. And so, Gary, it's our honor to have Tecnova as one of our design partners. It's an honor to have you here today.
Well, thank you.
Thanks.
Gary, tell us a little more about Tecnova and the type of customers you work with.
Gladly. Tecnova is a design services firm. We've been in existence since the early 80s, and we serve a variety of customers ranging from startup companies all the way up to Fortune 5 companies. Our clients are heavily industrial in focus. And we've designed really a lot of products ranging all over the place, from products that go into the birthing suite at a hospital to products that test, like the paper towel dispenser in your bathroom, all the way up to products that control water quality and report on water quality and control dispensing of product into a system to keep that water quality within bounds of purity and so forth. We have worked with a variety of customers to develop all sorts of applications, including electrical power delivery. So, like your ComEd, your Commonwealth Edison kind of companies. We have engineers who have experience in high voltage, power delivery, automotive electronics, like I said, water quality delivery, and vibratory monitoring and reporting. We've dabbled in medical applications, but it's not really where we focus. We focus in industrial. Our strength is designing robust controls, because our client base is industrial. Their controls, their products that they sell to their customers, they need to last. They need to have quality, and so that's where we focus in component selection, in design, all the aspects of making sure a design has performance, over a long period of time.
We love those words, performance and robust.
So do our customers.
And Gary, that's an impressive range of customer and industrial applications. Pete, walk us through the journey of USB evolution and how Type-C has addressed previous problems.
Sure, but how much time do we have here? But just kidding. So USB was invented about 30 years ago to simplify the way that peripherals would connect to a computer. And before USB, this was done by serial ports, parallel ports, and there was such a variety that it was quite messy. Ironically, USB's own evolution started to fuel much proliferation in terms of USB connector types. So pre-Type-C, it started with Type A and Type B, and then it went to mini, and then micro, and then super speed. You can imagine with all that variety, there was supply chain frustration, there was compatibility confusion in terms of keying types, orientation, things like that, and not to mention a few broken receptacles along the way.
Gary, as somebody who has works with customers in the industrial world, tell us about some of the frustration with the connectors prior to USB Type-C.
Well, as a consumer, I can offer two perspectives, consumer and design. But as a consumer, if you take a Type A or a Type B or even a micro or a mini, you have to pay attention to its orientation. Otherwise, you've got the attempt to force it in incorrectly, and sometimes you can break it. So with the micro USB connector, if you get it inserted in your connector and you bump it, how many of us have bent that plug in your cable and now have the tape around the cable sitting on your...
Not me.
Yeah, okay. And there's also bandwidth limitations, right? So the earlier USB 1.0, the USB 2.0, they're not equipped with the kind of bandwidth that USB 3.0 and 4.0.
Yeah, in consumers, we get frustrated. In industrial applications, you can stop production, which is a much more severe case. So then came USB Type-C. How did USB Type-C help solve some of these problems?
Well, USB Type-C, to Pete's point, it's symmetric. So the user doesn't have to fuss about, well, is it oriented correctly to get it inserted? One of the design perspective elements is that we have to design enclosures a lot of the time for our customers. So having a Type A or a Type B plug, as part of that design, that whole product design package, we have to leave space for that connector. And so with the bigger Type A and Type B plugs, obviously the enclosure gets a little bit more complex because you have to leave more space. With the Type-C, it's smaller. But unlike the micro and unlike the mini, right, it's not as fragile. And it's symmetric, so you don't have to worry about leaving finger room necessarily like you would for a micro or a mini.
Understood. Pete, tell us a little about our USB Type-C portfolio at Hirose.
Sure.
Especially some features for the industrial market.
We got plenty of those, and plenty of products too. So our USB Type-C portfolio is 34 products wide. Some cable assemblies, a few plugs, but mostly receptacles. So I'll talk probably most of you about our receptacles at this point. All of our products support the typical USB standards, so USB 2, USB 3, USB 4, and our products are used across multiple industries, consumer, industrial, and even automotive for our ruggedness, our focus on rugged, I should say. But true to form, as I mentioned earlier in our discussion, Hirose attempts to differentiate where we can. So one of our receptacles is industry's shortest depth. And then with some of our particular products, on our USB Type-C portfolio, of course, we offer 6 amps for faster charging capabilities. And I mentioned that one of the things we do happen to focus on is rugged applications. So what's the definition of rugged, right? And Pete's definition is there's table stakes or there's baseline. The first is it has to have high mating capability performance. And it also has to be waterproof. So that's my definition of table stakes. Now we need to one-up that. And the way we do that is through its peeling strength. So there's 2 options we have on our products for increased peeling strength. Layer 1, or level 1 if you will, is to offer the USB receptacles with through-hole reflow mounting posts. Okay? The second is, on top of that, we add 1 or 2 products that have screw mounting capability as well.
So through-hole reflow, also known as pinning paste, is a technology where features normally designed for through-hole technology and wave soldering can be used in reflow oven. Pete, walk us through a couple of cases where Hirose has helped customers.
Sure, absolutely. Now, I'll stick with the rugged theme, and we have 2 primary examples come to mind in terms of recent design wins. One is we're engaged with many medical customers. One had a design challenge. They were trying to go to market with a small portable medical device, and so one of their design considerations or design challenges were that they were PCB area constrained. They needed a USB Type-C, and so we offered ruggedness through that through-hole reflow, through those through-hole reflow mounting posts, if you will. But also, we offered them our shortest depth offering that we have, and that's the 6.3 millimeters in depth. So saving them PCB area space, if you will. The second application that comes to mind is one for an industrial point-of-sale device customer. And being industrial in nature, of course, it needed to be super rugged. And in this case, being industrial, and it needed to also be fast charging because they didn't want to have a lot of downtime with their particular device. So we offered the CX90 MW6, also known as the Terminator, and that's one of the discussions we had early on in our engagement when we were first courting each other for the Design Partner Network. But anyway, the attributes of the Terminator happens to be that not only does it offer those through-hole reflow mounting posts, it has the screw mounting as well, and as a bonus for the customer, it's what I call shover-proof. Okay, all right. I know it's not really a true spec, but the shover-proof, it actually correlates to it's called prying effect, and the way we accomplish this shover-proofness, if you will, is within the receptacle itself. We put 4 welding posts in there, and what that does is whomever is the operator, whether we're talking a force entry operator or someone who might be a little more delicate, is when they have the plug, these welding posts will actually prevent the plug from hitting the insulator in the back of the receptacle. So it helps prevent wear and tear on the receptacle, and hence will prolong the USB receptacle's life, if you will.
Happy to hear that Hirose focuses on our industrial applications. Any other cases, Pete?
Yeah. And so we, just like Tecnova, we value what our customers need. And so one of our large automotive OEM customers recently approached us because of the trust that we've established with them with prior designs and such. They needed a Type-C type of connector, but they needed it to be robust, automotive proof, if you will, right? So we took our CX90 core, we added additional housing around it, and as a result, we made that Type-C more robust, and we made it compliant to the U.S. car 2.0 standard and the US Car 30 standard.
And when was this product released?
Ah, yes. You're reading my mind. This happens to be the AU1, and we just recently released that to market about a week ago.
Talk about showing a new product introduction during the webinar. Gary, tell us about a case where you have helped customers.
Well, I can speak to one product design in particular that comes to mind. There's a customer of ours that has a device you can go buy off of a hardware store shelf. And their previous version had a USB micro connector and a USB mini connector. One was assigned for connecting power. The other was assigned for connecting data. And like we've talked about, those can be a little bit fragile. So we designed the next generation version of that product for them. You can go and buy it off the hardware store shelf today. But what we did for them is we combined the data and the power into a single connector. So now there's not two connectors, there's one. It saves on the bill of material cost, of course. We used USB-C instead of USB micro or USB mini for the obvious reasons that we've already covered. The USB-C, you can insert the plug in either of the two orientations. There's a little bit, if you look very carefully at the shell, there's a little bit of rounding, and so the insertion angle doesn't have to be so specific like you would have to care about with the USB micro. So that solved a lot of consumer, usability issues there.
Yeah, and Gary, before we started talking, you were mentioning that had you known about Hirose products, maybe you could have suggested that. Can you elaborate on that?
The Terminator.
Terminator.
So we did this design roughly 2 years ago, and then I met Pete, and Pete introduced me to the CX90MW, and immediately upon looking at it, I realized that had we known about this, had we had this relationship, that would have been the connector we used. We did use a mid-mount USB-C connector, and that's what the CX90MW is, but the CXM90 is such a great connector. We would use it again. We would use that in an application like that if we ever do that again.
That's good to hear, and we can see the importance of partnership. It's not
Yes.
just the connector itself. There are hardware design, manufacturing challenges that had to be considered as well. That's why these type of partnerships are very important to help our customers
Absolutely.
succeed in their product development. Thank you. We talk about the hardware part, the connectors, but sourcing has become also very important. And a hot topic is now tariffs. There's a risk of high tariffs. So I would like to hear about how Hirose and Tecnova minimizes that risk. Gary, what's your take on that?
There's some interesting advantages to using Tecnova and our sister company, Tecnova Electronics. Like I said before, Tecnova is a design services company. Our sister company, Tecnova Electronics, is a contract manufacturer. We're both located in the same brick and mortar facility in the U.S., and so our customers, they're concerned about paying more for components than they used to, and with tariffs, that's what's happening, right? And so they're also concerned, our customers, with acquiring assemblies that they can sell to their customers without having to pay tariffs. And so by our customers coming to Tecnova for design services, we can design in components that are USA based or sold by companies that are not subject to tariffs. And we can supply through Tecnova Electronics those assemblies from production to our customers without tariffs being applied to the sale of that product.
Because it would be US made.
That's right. Made in the USA,
Made in the
designed in the
USA.
USA.
Nice.
That's right.
Yeah.
And Pete, how does Hirose assess or manages the risk of tariffs?
Well, I can't say that we have that we're made in the USA. However, from the get-go, we've had a global diversified manufacturing footprint. We currently have 9 manufacturing facilities, but only 3 of which are in China. If you take a look specifically at our USB Type-C portfolio, only 20% of those are made in China. The rest, the 80%, are manufactured outside of China.
So this concludes our conversation about USB Type-C connectors. We learned about the connectors, the importance of design and manufacturing as well. Feel free to reach out to Hirose or Tecnova for further information. Let's open now to questions for the audience.
All right. Well, Jorge, Pete, and Gary, thanks for that really excellent panel discussion. Are you guys ready to answer some questions?
Most certainly.
All right, we already have some excellent questions from the audience, so I'll remind everyone there's still time to submit your questions. Just type them into the Q&A section on your screen, and I'm going to kick things off by asking my own question here. What is the most common misconception about USB-C that makes system designers hesitant to consider USB for an industrial application?
Well, that's an interesting question. The I'm not sure that I understand what misconceptions there might be, so I'm struggling to understand what.
Well, oh, sure. So let me elaborate, because I mean, most of us are familiar with using USB-C in commercial consumer applications, right? And it's not the most
Okay.
robust, and so it doesn't feel like a industrial connector to me. So
Oh, I
I'm
see.
thinking that that might be one of the misconceptions, but maybe not the only one.
Well, there's certainly some advantages, like we talked about here just before, with using USB-C that make it more desirable to use in an industrial situation than the Type A or the Type B for sure,
Mm,
just based on size.
mm,
With using the terminator, for example, as the receptacle for a USB Type-C plug, with the screw mounting provisions, I consider the USB-C just as robust, if not more robust, than some of the older, larger connectors.
mm.
Yeah, Dale, let me jump in. I paused at first because I was a bit taken aback because of all of the enablers with Type C, but I better understand your question through the context of the consumer over to the industrial space, right? So
Mhm.
um, it's one of those market trends where typically the products for consumer make it in over some time after cost points continue to come down, things like that. It migrates into other industries such as industrial. But as you heard, the biggest complement of USB Type C is really the simplicity of it because of its symmetrical design. Right, doesn't
Mhm.
matter if you with the plug, if you plug it in right side up or upside down, it's gonna mate. And then, secondly, specifically for the ruggedness, you heard about, the table stakes that we offer, but then the increased options that we have for peeling strength. So the through hole reflow mounting post being one of them, and then on top of that, the screw mounting options as well. So, we're dedicated, both Tecnova and Hirose are dedicated to help solving customer problems. And so by hearing those pain points, we continue to come out with next generation products that help solve those problems.
Yeah.
Yes, and I would like to add that we have some plugs with screw-mounted options to prevent things from being unplugged accidentally in an industrial application.
Mm. Yeah. Thank you guys for that. All right. Our next question is, what are the main benefits of AU1?
Yeah, so with the AU1 is specific for automotive. I should say it was a custom that we did for automotive. It could be used outside of the automotive industry, where the automotive specs would be used outside of automotive, like adjacent industries, for example. But anyway, the uniqueness of it is keying options. So with the AU1, there's some specific keying options that are used for not only for its robustness, but to ensure that there's no mismating, if you will. And then, as you saw in some of the video flyovers during our presentation, we added some additional housing to make it even more robust. So, with taking our core of the CX90, adding that additional housing, um, hopefully you heard that the AU1 is compliant to the U.S. CAR 2 standard and the U.S. CAR 30 standard as well.
Very good. All right, next question is asking what key design considerations should be factored in when integrating USB Type-C into a PCB layout for high reliability applications?
Well, the assumption I'm hearing is that mechanical robustness is probably the focus of this question, and it depends on the application and what the requirements are. Obviously, from the customer, who if it's a Tecnova customer, what their requirements are for this design. There are a couple areas of mechanical design focus that we keep in mind. One is the securing of the USB Type-C receptacle to the PCB, and that's where we've talked about the provisions for screw mounting through the ears.
Hmm.
the terminator. And then another is supporting and strain relieving the mated plug and cable. So you have this plug on the end of the cable, you plug into that connector. And so you obviously want to keep, you want to guard against mechanical levering of that mated plug from creating prying forces at the USB-C receptacle. So that's where we focus, is on the mechanics of it. It's, curing the USB-C Type C receptacle to the PCB, using enhanced provisions, possibly through the mounting tabs for the mounting screws, and also possibly by designing the enclosure so that the cable and the plug are supported as well.
And I would assume, just to follow up on that, that making sure that mechanical reliability is robust really keeps the signal integrity high.
Right, right. And that assumes that all of the good design practices are implemented behind the connector, right? That the electronics, the USB signal pair is routed with the appropriate, spacings and with the appropriate coupling to each other and not to surrounding planes, and that the ampacity, the current capability of the design is there. If that's, a feature of the USB-C connection that's important to that device.
Sure.
Yep.
Excellent. Okay, next question is asking, what are the hidden mechanical or electrical pitfalls of designing with USB Type-C in industrial environments, and how can they be mitigated?
Well, experience. No, I'm kidding. So seriously, the implementation of USB communications, it's always required specific, like I mentioned earlier, trace layout techniques. There's signal integrity for the USB signal pair in USB 1.0, 2.0. In USB Type-C, we're talking about signal pairs, plural. So getting that design behind the connectors, I keep saying, that's important. And so with the elevated, USB Type-C has elevated signaling bandwidth in comparison to USB 1 or 2. Requires more polished signal trace implementation than 1 or 2. And so, that's important to keep in mind. Those are pitfalls that can easily be stumbled across if the designer does not have that experience. Tecnova, we've designed a number of USB Type-C connections, and so we've got some pretty practiced approaches to this. We look at the optional elevated voltages and the currents, like I mentioned, that can be part of the USB Type-C implementation. We look at system engineering perspective really from the get-go, and so as we work with our customers, that's where we focus, is from the system level down to the details, getting into the weeds. But that system perspective gives us the overview and the insight that we need to know what is important electrically, what is important mechanically. So it's really a relationship building as much as it is, just gathering requirements so that we can understand where our customers' products go and what the applications look like.
Very good. Excellent. So this question is a little blast from the past, I guess, is what is Hirose's plan with RJ45 life expectancy?
Oh, interesting. So yeah, we would definitely like to see the market go over from the RJ45 to our iX. I had mentioned that at the beginning of our discussion here with the iX. The iX being 75% smaller in volume, the RJ45. So you can imagine how many more iXs you can get into a given space than the typical RJ45 connector. So from my viewpoint, I would definitely like to see quick migration over from the RJ45 over to our industrial Ethernet iX connector.
Okay, this question is specific for some of these applications. So this is what I love about these Q&As. So this person says, we use USB-C in high vibration environment, so the AU1 series looks very promising. Can you snap the plastic mating molding over basically any USB-C plug? Also, what is the smallest footprint right angle plug and receptacle in the AU1 series?
Oh boy, gee, I don't have those answers off the cuff. I apologize for that one. Let me make sure we capture that one, and I can get back to the person who asked that question. Thank you.
Yeah, absolutely. And I would assume you guys would, you're always happy to answer questions for people looking to solve their engineering problems. So,
Oh yeah, absolutely.
yeah.
Yes, and I would like to add that we are welcome to hear ideas to do a custom design depending on the application and the value.
Oh, that's an important add-on. Thank you, Jorge. All right. Our next question is, when replacing legacy USB connectors with Type-C, what unexpected design challenges typically arise? How have other engineers solved them, or have those challenges been solved?
Well,
Mhm.
there are some challenges. One challenge is in updating a USB connector from a legacy, to a USB Type-C connector is just simply the density of the pinout, right? The USB Type-C connector is a denser pinout. It has a smaller pitch or smaller space between the pins, and it's got a greater number of pins in addition. So the challenge is not just with designing the PCB trace layout, but also includes the selection of the PCB fabricator. Does the PCB fabricator have the capabilities you need for the application that now includes the USB Type-C connector? And then, of course, looking at the contract manufacturer's capabilities for accuracy in component placement, right? Do their pick and place machines have enough control and enough accuracy unit to unit within the panel and panel to panel within a mass production to accurately place that USB-C connector consistently? And so with the PCB fabrication, the smaller pitch, the distances between the pins, that can all be difficult for lower cost PCB fabricators, to produce units on a high volume basis with quality. With the CM, the contract manufacturer, the placement of the USB-C type connectors, that's, especially vertical orientation Type-C connectors, that's the vertical as opposed to the right angle, right? That requires a higher minimum quality and precision of the location of the connector X and Y, and also in Z. So using the placement force to place the connector into the solder paste, right? That requires a certain amount of control. If you don't force the connector well enough into the solder paste, it might vibrate off the board before it even gets into the reflow oven. And obviously you don't want to overstress it. So there's lots of TLC that goes into upgrading an older USB connector to a Type-C, but it's all completely doable. And Tecnova and Tecnova Electronics were very practiced at it, not just in designing it, but also in selecting quality vendors for the PCB and in selecting and using our production assembly equipment.
Excellent. Okay. This question, how do I make sure I'm balancing power, signal integrity, and mechanical durability when designing a USB Type-C interface? Are there common mistakes to avoid?
Gary, let me start off with that one if you don't mind, and then please add. But from our standpoint, Hirose standpoint, the USB standard itself does a lot of that for you, right? So that's the beauty of choosing one of the protocols. But I would say the main thing to keep in mind is don't go too long, and what I mean by that is depending on the USB standard, whether it's 2, 3, or 4, there's a limited reach, right? So the USB 2 standard, I believe, 5 meters in terms of max reach. The USB 3 is around 3 meters and such. So, just ensure that however far you want your peripheral to communicate, just keep the distance in mind.
Yeah, that's a great point. That's a great point. I think a lot of times inside or behind the connector, as I said before, and there's all sorts of details to attend to. With mechanical durability, the challenge can sometimes be, depending on the application, designing the enclosure to support the mated plug, right, without making the enclosure too complex, making it more difficult to produce. So there's oftentimes the compromise that has to be struck, or some creativity that has to be employed to make the solution robust and easy to produce. Again, Tecnova, we're practiced at doing that, and
we focus on PCB layout frequently, almost with every job, every design we touch. And so that's where we focus a lot of our energy is, implementing those signal pairs for the USB signaling, making sure that we've got the right design for the current demands that are in place with the application. But your point is stellar. Make the cables not too long.
Yeah, I would like to add that if you don't need high speed, we offer 16-pin versions that only have compatible with USB 2.0 that may simplify the PCB layout. Also, for the waterproof versions, we offer guidelines about the enclosures so that we could have the waterproof feature working well.
Mm-hmm.
Yeah, all good points. Thanks. This question, what should I keep in mind if I'm using USB Type-C for alternative communication protocols? How do I make sure my design stays voltage compliant?
Well, I would say don't do it. No,
Yeah,
but let me backtrack a little bit. You'll see that I kind of reached that conclusion at the end. But usually the communication protocol will dictate the connector type, right? Not vice versa. So with Ethernet communication, there's the RJ45 and the IX connector. With USB, there's the USB type of connectors, and of course today's discussion was on our USB Type-C connector. The premise of that question is really, where I'm rendering my answer is, if you use the USB Type-C, it could be inefficient. And what I mean by that is our Type-C connector we have 16-pin offerings and a 24-pin offerings only, right? So there could be the inefficiency. And then the second one is really more it could be more risky, especially because in the question it was voltage compliance, right? So, but to make it voltage compliance I'm going back many years now from my designer days, but the easy thing to do, so to speak, would be finding a USB adapter that gets to whatever protocol you might be wanting to use, or secondly is if there's no adapter available, well then you'd have to put in PCB board voltage and power protection perhaps, right? So you don't damage anything in the internal components on your PCB board.
Yeah, I mean, I agree with Pete that the basic first guidance is, well, don't do it. And then if you must, there's a lot of TLC. With the USB 1, it was kind of straightforward to quote unquote misapply or use the USB Type A or Type B connector with say maybe UART, because that was 5-volt compatible. But gosh, with the Type C connector, you've got a range of things you have to be compatible with it. You have to make sure it doesn't destroy your device and that your device doesn't destroy on the other end. There's Thunderbolt, there's DisplayPort, and then of course there's USB 3.2. So there's more and more scenarios to really guard against.
Yeah. Yeah, interesting. So this question, who's the right contact at Hirose to reach out to discuss customizing a USB-C snap lock solution, like similar to the AU1, and also is the AU1 available for samples?
Let's see. So let me answer. I would first start by reaching out to your local Hirose sales representative. Okay, and that person will get it to the right product manager. Of course, you can reach out directly to me. I'm more than happy. And I'm sorry, Dale, what was the second part of that question?
Is the AU1 available for samples?
Absolutely, yeah. If you go onto our website, you'll see that it is fully released, which means that we can sample and all that other good stuff.
Okay. This question is asking, does Hirose offer micro USB?
We do. So the two type of USB connectors that we offer are the Type-C that you heard about, and then we offer the our ZX series, which is the micro USB. So on our website, it would be, on our website, it would be, the micros would be known as our ZX series, and our Type-C are known as our CX series.
I'm going to just kind of follow up on that one.
I want to add that Hirose actually created the micro USB.
Oh, really? Oh, Awesome.
Oh yeah. First, thank you, Jorge. Thank you for that reminder. We were the first to be USB IF certified with the micro USB.
Okay. I was going to follow up on that. I was just curious because I know like the EU recently made Type C the standard for all new, at least consumer. I'm not sure of industrial. I never thought about it or looked into it. But are you seeing people still design in with some of those older USB technologies, or is the migration really driven to Type C today?
At Tecnova, I can speak for the last few projects I've been on have all been Type C. And one of those was, 2 years ago, that was the device we talked about being on the hardware store shelves today. But we've had a number of devices where we've implemented the USB Type C connector, for example, for a mobile or a pocket-sized vibration monitoring device, just to charge the battery.
Yeah, and I'd like to add that there was an European directive that require USB Type-C for porting charges in mobile devices. So that probably has accelerated the transition to USB Type-C.
And Dale, to answer your question from my perspective, we're seeing majority, 95% plus of new opportunities are with the Type C versus any other of the previous USB connectors. And it goes without saying that the type of enablers that Type C has provided to designers, to consumers is the reason why. The simplicity of use and the enabler with faster speeds and more power transfer, things like that.
Yeah, and all the examples you guys gave in that panel discussion makes it pretty understandable. So, well, it looks like we've reached the end of our questions. Jorge, Pete, Gary, any last thoughts before we sign off for the day?
Well, it was great to be part of this good Q&A, and looking forward to engaging potential customers more.
Excellent. So we do want to thank the audience for your participation. Again, Jorge, Pete, Gary, thanks for that, sticking around for the Q&A. Really lively discussion today. I appreciated it.
That's our pleasure.
Our pleasure.
Thank you so much, and we appreciate those that attended. Thank you.
Yeah.
Thank
In
you
just a
very much.
moment, everyone, you'll be redirected to Hirose's author page on All About Circuits. I'd encourage you to view their other resources available and visit their website. And you'll be able to view this session on demand by using the same link you used to view this webinar. Thanks to everyone for your time. We look forward to seeing you at another live session again sometime soon.